Hello everyone. In this video, we talk about basic data structures in Python. To get us started, let us quickly review the definition of a variable in Python. A variable is a symbolic name that represents or refers to a value. So let's say you want to store a number like 2 or 5 somewhere in the computer's memory. When you store this information, you have a specific address for that location in the memory. So one way to access the information about the value that you have stored is to remember the address for that location, but this is usually very complicated and it's not an easy task. Instead, what we do, we assign a label for a piece of data that we have stored in the memory, and that label is what we call it a variable. So therefore, variable is like a container that holds information. With this in mind, now we can define a data structure. So a data structure is a way of organizing and storing data so it can be used efficiently. This is particularly very useful if you have multiple pieces of information that you want to store, meaning that you're not just want to store one value like 2 or 5, you want to actually store, let's say, 100 different numbers, and you want to make sure that you can access them in a very efficient manner. And Python provides several built-in data structures that you can use them, such as lists, tuples, sets, and dictionaries. These are the very common data structures in Python that we need to know for machine learning and data science applications. And these structures allow you to organize and manipulate data in different ways. And although they are similar in some ways, but there are some subtle differences between them. For example, we are going to see in this video that lists in Python are ordered collection of items. So what order means that we have an index that shows the location or position of each item that you store. But on the other hand, a dictionary is an unordered collection of key value pairs, meaning that you lose that notion of location or position. And this is sometimes very helpful, as we're going to see. So therefore, we need to know different data structures to be able to handle different scenarios depending on the specific requirements for each problem. So let's just start with the basics, right? So let's just start with the variable. So we talk about these, that the equal sign is assignment operator. So this means that the value to the right of the equal sign is going to be assigned to the variable on the left side. So in this case, we're going to store this value to and give it a label or like a container, which is called x, right? So now when we type x here, we can see that we see the value that we have here. We can also do some operations on the right side of the equal sign. So here we are saying that we want to add 3 and 2, and then assign the result of this arithmetic operation to y. So in this case, you get y is equal to 5. Sometimes it is useful to know the list of all the variables that you have in a notebook. You want to, for example, see if you have used a variable name before or not. So in this case, you can use this percent sign and then WHOS. And this, if I run this cell, remember for running cells, I can use Shift Enter, or I can use the run option here. And in this case, we get the variable names, X and Y, their types, these are integers, and the value that we have for each one. So X is equal to 2, Y is equal to 5. So now let's talk about naming variables in Python, right? So as you expect, there should be some rules about, what a variable name can be. And it is recommended to follow these general rules that we have here. So variable names must begin with a letter, uppercase or lowercase, or an underscore. So this is something interesting. Actually, a variable name can start with an underscore, as we're going to see. And it is also a common thing to use underscore if you want to use multiple words in a variable name. And this is what we call it as a snake case, meaning that you have one word, underscore, and then another word, right? So this doesn't really mean anything. It's just more like remembering the general like way of defining a variable name. But there are some restrictions, right? So when you define a variable name, please do not use Python keywords or built-in functions. For example, we talk about the type function that we can use to find the type of any object in Python. You can say type equals 2, which means that you want to assign the value of 2 to type. But the problem is that now you lose all the functionality of type from now on, and you cannot use type for type checking that we discussed in the previous lecture. And the same thing for other keywords like if, else, for. We're going to see these in future lectures. So please do not use these keywords or built-in functions to define a variable name. And as I mentioned earlier with the snake case that you can see here, it is common that variable names are written in lowercase letters, right? So you obviously have the right to choose uppercase letters if you want, but it does really help to be consistent and follow several like general rules about that are especially the ones that are adopted in the Python community. And in this case, it is better to use lowercase letters for Python variables. And something else that we need to keep in mind is that a variable name in Python cannot start with a number. So you cannot start a variable name with a number, and that's something very important to consider. So let's look at some variables, right? So let's say we want to store the value 25. We assign this to age variable. We can have a string or character strings, like we use this double quotation to show that. And let's say we call this user underscore name. So now we know what this variable is actually username. You may want to, for example, store total score. That's what, again, we use this snake case convention. But you can also have multiple words, as you can see here, right? So you want to say something is a valid input or not. So you define this variable and assign some Boolean values, true or false. And you can see that I can run this cell with no problems. I can retrieve this information for any of these variables. In the next cell, you can see that we have this snake case, and then we have also a number at the end. This is totally fine. You cannot start a variable name with a number, but you can end it with a number, and there's no problem at all. And you can see it here, right? So in the next cell, that's the case that it's problematic because we are starting with a number, and this is not allowed. And you can see that we immediately get this error, which is called syntax error. So if you recall from the previous lecture, syntax error means that you're not following the grammar rules that you have in the programming language, right? And this error here means that you cannot start the variable name by number. But as mentioned earlier, you're more than welcome to use an underscore. This is actually something very helpful at some points. You can see that in this case, we can have a variable name that starts with an underscore. Okay, so before moving on to talking about data structures in Python, let's also talk about the fundamental data types. And there are 5 of these, right? So the first one is integers, or int, and this represents whole numbers without any decimal points. We have floating point numbers, which is called float, and this represent numbers with decimal points. The strings or character strings, which represent sequence of characters, such as text. Like, for example, we had before username equals Christina. So Christina is a string. We have Booleans that we saw in the previous lecture. BOOL represents either true or false values, right? This is very helpful with comparison and logical operators. And non-type, and that's none represents the absence of a value or a null value. And as mentioned before, one thing that you can always do to check the type of a variable is using the type function, right? So this is something you can always use. Here, 5 is obviously an integer because we don't have any decimal points. A is 3.14, and this is a floating point numbers, right? So that's why we get float. And then we get the strings, right? That you can be either in single or double quotes, right? I personally usually use double quotes, but either way is correct. And when we check the type, you can see we get str. We can also create a new cell here. So you can go to insert and insert cell below, and now check the type of, for example, true. So this is a Boolean, and you can see that we get BOOL, or we can create another cell here and type none, and this is when we get that none type, right? So which means that the absence of a value or a null value. The other thing that we can discuss here is that the len function, len in Python, is used to get the length or the number of items in an object. And if you're using len with the strings, in this case, it returns the number of characters in this string. So in this case, I define my underscore string, which is hello world. So this is the string that we have here. And if we count the number of elements here, so we have 13 elements here, right? Starting from H, going to the exclamation mark that we have at the very end. So this is very helpful, right? Because in Java, you may have a string, you don't know how many characters you have. And in this case, you can use len, and you immediately get the number of characters that you have here. Something to keep in mind here is that when you have this string, now you have this notion of ordered collection of items, right? Meaning that this H is the first element, E is the second element, then L is the third element, which means that now we can actually index them and use that indexing system to access them, right? So for example, you want to just, let's say, look at the second element, right? What index we have to use to select that element. So that's what we want to discuss in the next cell. So the way that indexing works in Python is that the first index is actually index 0, right? So this means that this P here, we are now changing the string that we have. We are calling it Python. And in this case, the first character that we have here is P. And the way that we can access this is using these square brackets. And then we put the index here, which is 0, meaning that the first element. Now, if you want to look at the second element or retrieve the second element, that element is index 1, right? Because indexing starts from 0. And now we can print these two characters that we have accessed. And the way that we can do this is using something called the print F double quotation syntax, which is called an F string, which stands for formatted string literal. So what does this mean? It means that we want to print something, and what we want to print really depends on the variables that we have before this print statement. And in this case, this means that we have to wait to see what those variables are to know exactly what it should be inside that print statement. In this case, you can use this F and the double quotation, and then you have these curly braces or curly brackets, and inside that, you put the variable that you want to print, right? So this means that when you use this print statement, Python is going to look at what this first character is, and first character is defined here, and it's going to print whatever that first character is, right? So you can see that if I run this cell, now we have the fixed part, which says the first character is, okay, that's always fixed. But what we have here really depends on this variable that we are accessing or defining here. And that's P because it's the first letter, index 0. And then the second one is the one at index 1, which is the second element or second character, and you get Y. So this F string or formatted string literal is very important and convenient way to embed variables within a string in a concise and readable manner, right? So in this case, everybody knows that you want to print this first character, and first character is defined in a few lines above that, where it is the element or character at index 0. So in this case, we only picked one element, right? But what we can do, we can actually pick multiple elements. And in this case, this is called a slicing, right? So a slicing is a technique used to extract a portion of a sequence, right? So it can be one, but it can be more than one. And you can use it for strings like we do here, and later with lists, tuples, etc. So we're going to talk about lists and tuples soon, but we know right now about the strings. And the syntax, or the way that you can define this slicing operation, is using these square brackets, a start index, colon, end index, colon, and then the step that you want to use. So start is the index of the first element you want to pick. End is the index of the element just after the last element you want to pick. So what this means is that when you're using a slicing, you have the left side and the right side, and the left side is inclusive, which means that it's included, but the right side is exclusive, which means that you want to go up to, but not including the end index. So in this case, if you want to pick something, the last one that you pick is at index, let's say 4, then you have to set this end to be 5 because it's exclusive. This means that automatically you will stop at 4, including 4, but you will not include 5. And also you have this step argument here, which is the number of indices between each slice, right? So when you start from the start index, do you want to go one by one, or you want to skip one element and pick the one after that, right? So that would be then step equals 2. But usually the default value is 1, meaning that you want to pick all elements. So to see how this works, let's look at my string, right? So you can see that here we have Python. That's the string that we are working with. And again, this single or double quotation really doesn't matter. This string is Python. So what is my string 1 to 4? Remember, this is the start, this is the end. And in this case, we have not defined the third one, which is a step. You can just leave it empty, and in this way, you know that the default value is 1. So what this means is that you want to pick elements from index 1, and remember, indexing starts from 0, and up to index 4, not including the one at index 4. Okay, so now if we look at here, we have Python, and I'm showing the indices for each one. So it starts from 0, 1, 2, 3, 4, and 5. So in this case, we are saying that we want to start from index 1, which is this one. So this means that the first element or character that we are selecting is Y. And then we go to 2 and 3, but not 4, because that's exclusive. So what this should give you is YTH. So let's run this to see whether we get this. And in this case, we can see that we get YTH, right? So that's exactly how this works. The start index is inclusive and the end index is exclusive. However, if we want, we can really use that step parameter or argument too. In this case, it wouldn't make any difference because we are selecting all these elements from first to end index. But if you want, for example, in this case, to increase the step from 1 to 2, you can see that we will pick Y, and then we jump over T and we select H. And that's what exactly we get here, right? So this is the idea behind the slicing, where you have a start, a stop, and a step index. And there are default values for each of these arguments in the slicing operation. For start is always the beginning of the sequence if you don't specify it, meaning that index 0. For end is always the end of the sequence if we don't specify it. And for step, the default value is always 1, meaning that you want to pick every element from a start to end index. So you can see that here we have another example that we are saying that we want to pick everything up to index 4, but excluding index 4, right? So that's the thing with always with the end index. And you can see that we include this time this p, so it would be pyth. And then similarly, we can start from the second character and go to the end of this list, right? So in this case, you can see that we get Python without p, right? Because p is at index 0. And here we want to say that we want to start from index 1. Something which is very interesting about Python is that you can actually use negative indices, and negative indices indicate that you want to count from the end of the string or end of the sequence. For instance, -1 represents the last character in a string, -2 denotes the second to last character, and so forth, right? So here we have the string Python. What this says is that you want to select the element at index 2. So p is 0, y is 1, t is index 2, and go up to -2, right? So this time you're going to count from the end of this sequence. So n is -1, o is -2, and that's excluding because it's a stop index or end index. So in this case, if we run this, you can see that we get only t and h, and we do not get O, right? Because O is -2 index, and we go one before then, right? So which is like the H here. And this negative indexing system is very powerful. Like one thing that you can use, which is really cool, is this notation. And just to put this in context, what it is here is that, remember, you always put your start index here, and the end index here, and then the step here. And in this case, we put the step -1, and we do not specify a start or end indices. So what this really does is gonna go pass through the sequence in reverse order, right? Because this means that you have included everything from the beginning to end of this sequence, but instead of having a positive steps where you go from left to right, now you go from right to left, right? And if you can see that, you see that you get this, first N, then O, then H, then T, Y, and P. So now you have this sequence in reverse. So this is a very cool trick that you can use with negative indexing. The other thing which is very important in Python, and here we are showing all these examples with the strings because it's very easy and straightforward to use these strings, is that because it's an object and we are following the principles of object-oriented programming, you can use very special functions or methods for manipulating these types of objects. For example, for strings, you can use this method which is called upper. And the way that you use this is that you have here your string name, whatever it is, and then this dot notation, and then the method name or function name. And don't forget the parentheses because this is a function. And for functions in Python, you have to use parentheses. And what this does is that, as you can see in this comment, it turns your strings to uppercase letters, right? So now we have all uppercase letters. So let's say you want to do some data analysis with some emails, and you want to make sure that all letters are uppercase, you can use that upper. You can see that this doesn't necessarily change your original string. It just creates a new version of it. So it's not stored yet. Our string still is Python. Since you have dot upper, this means that we have dot lower. Now everything is in lowercase letters, right? So if it's not case sensitive, you want to make sure that you can use, for example, dot lower, so that if somebody use uppercase letters, now they're converted all to lowercase letters. There are also many other cool methods that you can use with the strings. For example, you can check to see if in the string starts with a specified prefix, like dot starts with. And in this case, we're saying that is this a string that we have? It starts with uppercase P, and the result is this Boolean true. Yes, that is the case. And you can also, for example, find the index of the first occurrence of a substring. Is there th in the string that we have? The answer is yes. And if you want to know when that happens, is 0, 1, 2, right? So it starts at index 2 where we have this th or this substring. And this is what you can see here. And this is just to show that we never really changed my string. So that's saved in somewhere in the computer's memory. You have this label for it. And all these methods, they just create a new version of that string, and they are not stored unless if you assign them to another variable, and you want that way you can store it. But otherwise, we never really changed the original string that we have. Okay, so now that we know about variables, fundamental data types, and also this indexing system in Python, which is something that we can also use for other data structures, let's just start with the most important data structure, or the most common one, which is list. So what are lists in Python? Lists are ordered collection of items, which means that you have an indexing system that you can use to find the position of items. They are mutable. What this means is that you can modify their elements by assigning new values. You can add or remove items. So you have all the options to modify the list as you wish. And there are heterogeneous elements, meaning that you can list can contain elements of different data types. You can have a list of numbers and strings, or even list of lists. And also the way that you define lists is using a square brackets, right? We have seen this before, that for creating lists, we need to use the square brackets. And you can use common operations such as concatenation, which is the plus here. So this is not an arithmetic operation here, because you're not working with just with like numbers. You're working actually with list here. So if you use one list plus another list, really there's nothing to add there in the arithmetic sense. This means that you want to concatenate the two lists. You can use repetition using asterisk, or you can use the len function to find the number of elements in your list. And also there are specialized methods or functions that you can use for manipulating lists, like adding, removing, sorting, etc. And we cover some of these here, but whenever you need these methods, you can always search online and find what an appropriate method is for the task you want to do. It's very likely in many cases that you can immediately find some built-in methods or functions. And also lists in Python, they have dynamic sizes, meaning that they can grow or shrink, and also you can add or remove items and elements as needed. So let's look at a few of examples of what we just talked about, right? So here we create this list one, has 3 elements, 1, 2, 3, right? So this is now a container for multiple variables, not just one. We can look at the type, and you can see that we get list as expected. We create a second list. We call it list underscore 2. This list has strings, right? Apple and orange. We have this double quotation. Now we can use this plus sign here. And then remember, this plus sign is not an arithmetic operation here, because you have list. And what really happens here is that when you add these two lists, you concatenate them. Now you have a list which contains the 2 other lists that we have that are elements, right? So now we have 5 elements here. And you can always find the number of elements using the len or len function, right? So 5 elements. So what is the difference between using this plus sign for concatenation or defining another list which contains the 2 lists that we just talked about, right? So if I run this, you can see that this is a different type of concatenation, because we really do not have one list that contains all the 5 elements. We actually have a list, right? So these are these outer square brackets that contains 2 elements. And the first element is another list, which contains 1, 2, and 3. And then the second element is another list that contains the 2 strings that we have. So now, based on what we said, if I just use what is the length of list 4, is actually 2, right? Because I have a list. Look at the outer square brackets that we have. That has 2 elements. That's element 1. That's element 2. So this len function is not going to look at the inner list that we have. It just looks at the outer list that we have and figure out the number of elements that we have. And as mentioned earlier, the slicing notation works here too, right? So I want to, for example, pick up elements up to index 2, right? So remember, it starts with index 0, index 1, index 2, but index 2 is excluded. So this means that you're going to just have another list which contains the first two elements, 1 and 2. And similarly, we said that we can use like negative indexing. So in this case, if you say -1, means that pick up the element that is at the end of this list, which is orange, right? So this is very helpful if you don't know the length of this list and you just want to pick the last one. You do not have to count all the way from beginning to the end of this list. You just say that pick whatever it is in the last one. Or we can, for example, say here that I want to look at this list 3 and pick the element which is at index -2, right? This means that from the end of this list, not the last one, but second to last one, right? And that's Apple, right? So you can see all the principles we talk about for slicing strings, they apply here too for lists. And now let's talk about some of the methods or functions that you can use for lists. And in this case, we're looking at list 3, which was the concatenation of the list 1 and 2 that we had. And you can use this .append, which is very useful. This means that you want to add something to this list that you already have. So in this case, if I run this cell, you can see that I have my original list. And now I appended or added this element, which is 4. Right. So in this case, now you have a list that contains 6 elements, right? We had originally 5 elements. We added the 6th one, and that's the length of this list 3. And something that is very helpful when you're doing machine learning and data science sometimes is to create an empty list, right? And then add new elements to this list later on using the append method, right? So this is the power of Python list, that it's dynamic. So it means that it can grow or shrink in size. And the way that you can create an empty list is just by using the square brackets here, but nothing inside it. This means that this is a list, but it's an empty list. And now you can, for example, append 1. You want to store the value 1. And now you want to store the string 2. And if I look at my list at the end, has 2 elements as expected, right? So you can do something multiple times, and every time you get some result, you can use .append. Similarly, maybe you want to add something to a list, but at a very specific location rather than just adding it to the end of the list. In this case, you can use the insert method, right? So in this case, the syntax or the way that you can tell this to Python is using this method or function insert index, which shows you at what index and what is that element that you want to put in that index, right? So that's something important to remember, right? The first one is index, the second argument is element. It's not the other way around. And obviously, when you do that, then you need to make sure that to understand that the existing elements at that index and after that index they need to be shifted to accommodate the new element, right? Because you cannot have 2 elements in one index, right? This means that everything at that index and to the right side needs to be shifted by 1, right? So in this case, we had the my list, which was 1 and 2. We are saying that at index 1, which is this index here, we want to put the string 3. This means that now I have 3 in index 1, which is the second location, and this 2, which was at index 1, now is at index 2, right? So remember, indexing starts from 0, 0, 1, 2. There are also a lot of other things that we can do with this. For example, you can check whether an element is in the list using the operator in. That's why I really like Python. It's very readable. It's almost like the way that we talk and explain things in plain English. So you can say, is the string 3 in my list, right? So the answer to this is true because yes, it is here 3 here. And then is the string 4 in this list? I cannot find 4 here. So the result should be no or false. And you can see that that's what we get here, right? So these are very useful operations that you're going to see a lot in machine learning and data science applications. Okay, so now that we talk about lists, now let's talk about tuples. So what are tuples? Tuples are also ordered collection of elements. So this means that you can use the same principles of indexing each element. But here is the first main difference. Tuples are immutable. This means that once they are created, their elements cannot be modified or changed, right? So if you say that I want to change the element at index 2 and before it was 2, now I want to make it 5, you get a very nice error message that you cannot do this, right? And this is a good thing in some cases. You may want to make sure that nobody changes what you have stored in a tuple. And that's when you have to use tuple, compared to, for example, like a Python list. And similar to list, tuples can have heterogeneous elements. You can have elements of different types, strings, floats, integers, etc. And the way you can define them is using these parentheses, right? So for list, you use square brackets. For tuples, you just use parentheses. And there are also methods or functions that you can use, such as concatenation. If you want to concatenate two tuples, you can use the length function. You can repeat a tuple. Something which is very important is when you have a tuple that has only one element. Obviously, you're allowed to do that. But something to keep in mind is that in this case, you must use a trailing comma. So what this means is that in this case, I have a tuple that I want to store the value of 42, but I do have to use this comma here. If I do not use this will not have the tuple data structure, and we're going to talk about this in the very next cell. And obviously, the other nice thing about tuples, you can use packing and unpacking. And what this means is that you can pack multiple values in a single tuple, and you can unpack multiple values that you have in a tuple when you need to. So this is what is known as packing and unpacking. So it's very much like what we really, say in plain English when you want to pack multiple things together and you want to unpack them, right? Think of that as packing and unpacking your luggage. Okay, so let's just start with the examples for tuples. The very first thing is that if you want to define a tuple with one element, if you don't use that trailing comma and you look at the type, this is an integer. This means that these parentheses that we have here, they do nothing for us to define a tuple here. So how you can make it a tuple? By using this trailing comma here, right? And if I look at the type here, you can see that now this is a tuple, which is great. Now let's create another tuple, which is 246. We use parentheses. You can check the type of this, and you can see that this is a tuple. Let's say for whatever reason, I want to change this third element, which is at index 2, to be 8 instead of 6. And if I run this, you get this very nice error message that says tuple object does not support item assignment. So that's what we meant by tuples being immutable. And then you can also look at the length of a tuple. So in this case, we have 3 elements, and that's what we expect to get 246. So let's talk about the packing and unpacking we said. So packing refers to the process of combining multiple values in a single tuple. And in this case, you can see that I have 1, 2, 3, and I just assign this to this variable called pack tuple. And in this case, recall that we don't have only one value that we want to assign to this. Actually, we have 1, 2, two integers and a string. And therefore, if we do this operation here, you can immediately see that now we have this parentheses, which is a sign that this is a tuple. And you can always check the type of this object, and you can see that yes, it is a tuple, right? So this is what is known as packing. You assign multiple values to a single variable, and by default, this will be a tuple. So what is unpacking? Unpacking is the opposite of packing, right? So in this case, you want to extract values from a tuple. So in this case, we define a tuple such as 1, 2, 3, and now you want to unpack it, right? You want to access these individual elements, And since we have three elements, I'm using three variable names here, A, B, C, and assign my tuple to these. And Python is smart enough to know that, well, I have three elements in my tuple, and I have three variables here, A, B, C. So I'm going to assign the first one to A, the second one to B, and the third one to C. So this is what is known as unpacking. And now you can see that if I check type of A, because now it's just one by itself, this means that this is an integer, right? Or if I check type of C, you can see that we get a string. Okay, so let's put this back where it was. Something which is really powerful when you're using unpacking, you can use the asterisk operator. So what does this mean? So let's say in this case, you have my tuple, which has 5 elements, and you want to separate the first element from the rest of them, but you don't want to individually unpack the remainder of elements that you have. So in this case, you use something very similar to what we used before for unpacking. So you have this variable called first. And if you wanted to follow the same like principles, now we have to call like second, third, fourth. Basically, we have to have 5 variables here. But I do not really want to separate the rest of them. So you use this asterisk here and you give it a name. I just call it rest here or something else. And once you run this, you can see that now we have this very nice way of selecting the first element and letting the rest of them to be still together. So this asterisk here is very important because if I don't have this, obviously Python doesn't know what to do with it because it says that, well, you know, I have too many values to unpack, right? And you have like 2 variables here, right? You need to add more variables on the left side of this equals sign. But if I put this star here, Python knows that, well, we want to use this trick where we want to pick the first element and then the rest of them all like pack together during this unpacking process. And that's how it works. Okay, so now let's go to the zip function. So my goal here is that to slowly introduce you to different very useful functions in Python. You know about print, you know about len or len, you know about type, type, where you can find the type of any object. Another thing which is very useful to have in your toolbox is the zip function. And what zip function does, it combine elements from 2 or more iterables. We're going to very precisely define what iterables are, but iterables are things like lists, means that you can iterate over the elements of a list, right? You can start from index 0, go to the end of the list. And what this zip function does, it creates tuples from corresponding elements from the 2 lists that you have, which means that it pairs elements at the same position and create tuples combining these elements from this input list that we have. In this case, we have list 1 has 3 elements, 1, 2, 3. List 2 has A, B, C. So when you say zip list 1 and list 2, what this does is gonna look at 1 and A, so because these are both at index 0, and put them together in a tuple, and then move on to the next one, which is 2 and B, put them in a tuple, and then 3 and C. And what it does, it creates a list of these tuples, right? So if I run this cell, you can see that I have a list because I have these square brackets. And then the first element of this list is a tuple, which contains 1 and A, 2 and B, and then 3 and C as the third element in this list. So this is sometimes very helpful that you might have, think about it in this way, in a mathematical sense, you may have like XY coordinates, a 2-dimensional plane. And in this case, you want to have each X coordinate to be paired with a Y coordinate, right? So you can have a list of X coordinates, list of Y coordinates, and then use this zip to have this 2-dimensional coordinate system that you need. Next, let's move on to the third data structure that we have here. So far we talk about lists and tuples. Now we talk about sets. So what is the main difference here? Sets are an unordered collection of elements, right? So this means that now you don't have anymore the indexing system that we talk about. We said that index 0, index 1, That's when you have an ordered collection. But in this case, we have an unordered collection of elements. And what this means is that, or what this implies is that each element in a set must be unique. In that sense, means that you cannot have, let's say, one or two, like multiple times in a set, right? So all the elements in the set must be unique. But sets are mutable, meaning that you can add or remove elements after the set is created. You cannot have duplicate elements, as we said. And in order to define them, you can use curly braces, right? So that's reserved for sets. And as we said, because we have an unordered collection of elements, there is no indexing or slicing you can use here. In this case, we are using these curly braces. We define the set my set. And you can use the add method to add an element here. So you can see that now we added 5 to this set that we have. We can use the len or len function. And we have 5 elements as we expect. You can say that you want to remove 2 from this set. That's using dot remove. And you can see that 2 is now removed. It's not there anymore. And let's say what happens if I add 1 to this set that we have. Since already I have 1 here, right? So you can see that really we cannot add it one more time. It's already there, right? So you cannot have duplicate elements. And you can see that if for whatever reason you want to do indexing here, you get a message here, error message, right? The type error that says that set object is not subscriptable, right? So this means that you cannot really do indexing here because there's no notion of location or position between these elements that we have here. The last data structure that we really need a lot, or we use a lot in machine learning and data science, is the dictionary. So what is a dictionary? Dictionaries are unordered collection of key value pairs. So there is no more indexing here, like what we had with list or tuples. We could use indexing and slicing. In this case, we cannot do those things. Dictionaries are mutable, meaning that you can add, remove, modify key value pairs. And again, the key thing here is that because of the way that dictionaries are structured, using these key value pairs, now you can access values using corresponding keys, right? And the way that this works is that you can have, let's say, a dictionary here that we define, and we have a key, which is name, and the value, which is John, right? So that's what we call a key value pair. They are separated by a colon. That's how you notice that how you define key value pairs. And then you have age 25, right? So in this case, we can define a list that contains John and 25, but then you have to memorize or remember that John is, or the name is the one at index 0 and age is at index 1, right? So it's kind of like hard to remember that, right? And let's say you want to do some data analysis, you need to retrieve that information. In this case, when you define a dictionary, you don't have to remember the location, right? You just need to know what key you used before. Use the name key. So now just retrieve what is included or in the name key. So that's how the information retrieval works. And the way that you can define dictionaries is using curly braces, like very similar to what you did with sets. But remember, in this case, you need to have these key colon value pairs, right? So that's how you can distinguish between them. And as we said, in order to accessing values, you just use the name of the dictionary, you pass the key, and then you get the value, right? So this is something that makes it much easier, right, than remembering the location or the index of elements. In this case, we have a dictionary. We're using curly braces or brackets. We have this key value pairs. So this is key value pair number 1, key value pair number 2, and number 3. But again, we do not have indexing here. Just remember that. So this means that now, let's say, look at the type of this, and you get a dictionary or DICT. And now if you want to look at the name of this person, there's, you have the information in this dictionary, you just use my underscore dict and then use name, right? And in this case, we should be able to get John, right? Because that's the key value pair that we have. And you have a lot of interesting methods here. Let's say you want to know what are all the keys that you have in a dictionary. It is likely that somebody gives you a Python dictionary. You don't know what keys they use. You want to know, do like exploratory data analysis. So in this case, use .keys, and this will give you a list of all the keys, right? Name, age, city. Is that true? Name, age, and city. Yes, these are the keys that we have. And then you can pick these keys and look at the corresponding values as you want. We can also look at all the values too, if you want. And in this case, you can say, what are all the values that I have in my dictionary? And you can see that we have John 25 and then New York, right? And you can also use like len, that we have used before. So in this case, this means that we have 3 key value pairs. Remember, we are not counting these individually because these two things are actually together. It's a key value pair. So we have 1, 2, 3 key value pairs. And very similar to dictionary to Python lists, for dictionaries, we can create an empty dictionary using curly braces with nothing in it. And in that case, you can add key value pairs to this empty dictionary later by assigning values to a specific keys, right? So in this case, I create this empty dictionary, and then I'm gonna say that I want to have this key and this value. So this is an assignment operator. I want to have this key, which is age, and this value. And if I look at my dictionary, you can see that, yes, we have created these 2 keys and we have the corresponding values stored there, right? Which makes it much easier to retrieve this information later on. But let's say with this dictionary that we want to see whether the key city exists in this dictionary or not. And again, we use the in operator that we saw before with list. And in this case, this automatically looks for all the keys that we have in this dictionary and returns true if city is one of those keys, and if not, you get false. So in this case, it's false because this dictionary only has name and age keys. But for name, if I run this, you can see that we get true. The last method or function that we want to talk about with dictionaries is .items. This is very helpful because what it really does is that it returns a list of key value pairs in the dictionary as tuples, right? So this is my dictionary that I have, right? You have these key value pairs. And this, what it does, these items, so you can see that you have this thing that looks like a list because you have these square brackets. And now you have these tuples, right? The first element is a tuple. You have key and corresponding value. And then you have another tuple, which is the key age and the value. So if you prefer to work with tuples, you can always use the name of dictionary items. And in this case, you get a list of all these tuples, which they contain key value pairs. And you can see that here we only have 2 key value pairs, so we have 2 tuples. And similar to lecture 1, we have homework assignments for this lecture. In this case, we are going to look at some of the basics of what we just mentioned about slicing, indexing, working with tuples, and be able to modify or change values. And also, we have a very interesting problem here where you're given a list and you want to divide these into 3 equal parts or chunks, right? So here, for example, you can use the len function to find the length of this and then divide it possibly by 3. So this means that you know what should be the size of each part or chunk, and based on that, you can do indexing and so on. So I hope you found this video helpful, and please let me know if you have any questions.